Our textbook has a section on the forensic application of chromatography. Chromatography is based on an old observation that inks and dyes actually contain a mixture of colors, and those colors can be separated on paper. Well, that has evolved into modern techniques, some of which are instrumental, that allow us to separate the components of a mixture. And we do that on what is called a stationary phase, that is a hard surface. Many modern drug tests involve an application of this method of chromatography. So I'm going to try and demonstrate a simple chromatographic experiment on a piece of filter paper. Basically any kind of paper will do, but the more uniform the weave of the paper is, the better the results become. Okay, I've got a piece of paper and there's an ink dot on it that is ascribed with a little question mark. That's a sample of ink that I'm going to pretend that I found at a crime scene. I'm then going to pretend that I collected the pens of 4 people who are at that crime scene and see if any of the ink in their pens matches the ink in the perhaps incriminating letter. So I've gone ahead and made dots on this paper with ink from pens that I collected from close to the crime scene, and then I'm going to take this paper and put it in a beaker of water. Now, I'll move this so that we can get a better view. There you go. Capillary action is going to make the water rise up this paper, and as it does so, what we hope to see is that some of the ink will be soluble in the water, and the different amounts of solubility that I have of the different dye components that are in the solution of ink will begin to separate. So very early on, we can already determine that the spot labeled A is very different than the spot that is ascribed to the criminal. So we can immediately rule out A as being a suspect. Let's give this a few minutes to develop, and we'll check back in when the water has risen further up the paper. Got a long way to go yet. It's been several minutes and the chromatograph has developed, and we can see that the unknown ink in the first column matches that belongs to sample C. It has a black blob and a blue stripy tinge to it. Therefore, I would be most interested in talking to the person who is the owner of pen C when it comes to finding out who wrote the incriminating note in my case. In the interests of science, I'm going to repeat the experiment, but instead of using water as a solvent, I'm going to use alcohol. Let's leave that in there and see if our results are any different. This separation using alcohol as a solvent has been running for several minutes now, and you can see that because the solubilities of the dyes in the ink are different in alcohol than they were to water, that the shapes and the colors here are different. But we can still see that sample C closely resembles our unknown sample. and that the other samples do not. So here are the results of our two chromatographic separations side by side. The one on the left was run with water as a solvent, and the one on the right was run with alcohol as a solvent. You can see that there's a difference in the vibrancy of the colors of the dyes and a difference in how far and in which order the spots have moved. All the same, this sample and that sample, A and C, clearly are a matched couple, and here the unknown and C are also a matched couple. This would be evidence enough for me to say that pen C was the pen with the same kind of ink that wrote the incriminating letter that I'm investigating.